Okay, so we're going to do some kind of trig application stuff today. So we're going to look at trig graphing applications. Okay, so we got trig graphing applications. And there's going to be a couple different phases to this, but the first thing I just want to, revisit the idea of what basic cos and basic sine look like, because I think it's worth, repeating and thinking about that. So I'm going to show you that this is going to be sine here. And recall sine at its most basic has an amplitude of 1. So I say just sine, but in reality it's y equals the sine of x, I guess more specifically, and this one down here will be y equals the cosine of x. And cosine of x also has an amplitude of 1, so it goes there. And they both have a period length of 360 degrees, so period length of 360 degrees. So in that regard, they're extremely similar, both of them. The basic graph has no phase shift, and the period length isn't altered. So I'm going to put in some framers here because it just always makes my graphs look marginally better, although they don't look fantastic when I'm drawing them on the tablet here. So I'll put those in, put those in, put those in. Okay, so they both have the same period length. So here we go. Sine, it's, we need to remember it starts at its midpoint and it goes up to the max, comes back down through the middle and comes up here, and that's one period length. So I always like to find and mark where the middle of the function is. And in fact, cosine, it's going to hit at the bottom down here. So I'm going to include that. Here goes sine, goes up to the top, curves over, comes down, curves up, and comes back up. And that's only one period. It keeps going, because it's sinusoidal, means it keeps on doing its thing. Cosine is similar, but it starts at the maximum instead of starting at the center. So it goes like this, comes back down, bumps there, comes back up, and goes like that. And again, it's a smooth curvature. It is not just a straight, sawtooth line. So just want to be aware of that. Now, I mentioned that, we've also already played, not graphing, but we've certainly used y equals, or we've used the tan. I'm not going to ask you to graph it, but I thought I would show you just the once. Tan, there's something called trig identities, and trig identities is something that comes in very prominently in grade 11 university and in grade 12 advanced functions. And one of the trig identities that is fundamental, that we use a lot, is the tan of x is actually equal to the sine of x over the cosine of x. And that kind of plays out if we think about SOHCAHTOA, right? We know SOHCAHTOA. And if we think about sine is the sine of x equals opposite over hypotenuse, and the cosine of x equals adjacent over hypotenuse. And tan, we know, well, tan is opposite over adjacent. And look how that plays out. If I do sine x divided by cos x, that means that O over H is going to be divided by A over H. So if I take that offline over here, if I said O over H is going to be divided by A over H, because I said that tan is sine over cos. So there's sine, there's cos. If I divide them for fractional division, you might not remember, but if you do fractional division, when you do it, you take the first fraction and you leave it alone. I'm just going to write it in this form, even though we hardly ever do it, but for fractions it makes sense. And we take and we reciprocate the second fraction, so it's O over H times H over A, and look what happens. Those guys are going to divide out, they're going to cancel out, and I'm going to be left with O over A. So there it is, tan is O over A, which is lovely. So how that plays out in graphing terms, and again, I'm never going to ask you to do it, I just want you to see it once. So if we do some division here, so this guy is going to be, grab some blue or purple or whatever that is, y equals the tan of x. Well, if we think about tan as being sine x over the cosine of x, anywhere that sine is 0, that means that tan is going to be 0 divided by something. Well, 0 divided by anything is 0. So anywhere that sine is 0, right, because this is 0 here, anywhere that sine is 0 means that tan is also going to be 0. So tan goes through those spots right there. Okay. Now, a weird one is that anywhere that cosine is 0, so here and here, if I divide by 0, we should know by now, hopefully, that when you divide by 0, bad things happen. So what that looks like in terms of the graph of tan, we end up getting this thing called a vertical asymptote. So I'm going to put these in, and they're going to be used differently than these ones up here are. So we're going to get a vertical asymptote anywhere that cosine is 0. Now, that's all well and good. Still don't really have any idea what this is going to look like. Some weird math, but if we think about from here over, right? So if we think about, this is 360 degrees, which means that this is 180 degrees, which means that this, well, this is 90 degrees. And this is also 90 degrees. So anything less than 90 degrees, between 0 and 90 degrees, we're going to get a positive value of sine, which is the numerator, divided by a positive value of cos, which is also in the denominator. A positive divided by a positive is a positive. So it's kind of a weird one. It ends up going like this, right? And then, we don't really show it because I'm not showing it, but it would go like that. And then over here, this pattern just repeats. It goes like this, goes up forever and down forever. And the same thing happens here. Up forever and down forever. And that's what tan looks like. It's just a series of these, very steep, almost vertical lines. And so that's what y equals tan x looks like. I'm not going to ask you to do that. However, I am going to ask you to come up with determining what equation something was in order to get the graph that I am going to show you. So we know how to graph. We spent the last couple of days or couple of lessons learning how to graph all of our sine and cos functions. What we're going to do now is we're going to go backwards. I'm going to give you a graph, and I'm going to kind of talk about how we can go through and we can figure out exactly what function it must have been that it was that we have graphed. So I'm going to go ahead and I'm going to sketch one, and then I'm going to ask you to pause it and see if you can come up with what you figure the equation must have been, right? So if we think about, it's got to look like, oh, stop that. If we had y equals a sine or cos of bx plus c plus d. I'm going to put up this graph, and you're going to try and tell me, is it sine or cos, what the a value must have been, what the b value must have been, what the c value must have been, and what the d value must have been. We're going to talk about strategies we can do that. For some of you, this is going to be, pretty in your wheelhouse, and you're going to have no real big problem with it. And others of you are going to have to really kind of practice and struggle with a little bit, and that's okay. So I'm going to put in my framers just to kind of make all of our lives easier. So here comes some framers, and we'll start out with a fairly easy one. How about we just do this and this? So I'll try and normally give you 2 full period lengths just because it makes it more obvious what's going on. So imagine that we had the following values. So I'm going to tell you that this is 12, this is 4, and this is -4. And you should be able to kind of think about, what are those things telling us right now? And then I'm going to say, obviously, this is 0, right? It's on the y-axis, so it's 0. And I'm going to say, we'll keep it easy. I say this is 180, and this is 360, and they're both degrees. Okay, so let's go with this one. So I'm going to just sketch it in, and I'll do my best to make it smooth, although it won't end up being, I'm sure. So it's going to go, not very nice. Nevertheless, it goes like this. Okay, it's about as smooth as I can get it. So go ahead, pause the video, and see if you can come up with, what these values are going to be substituted in, and you're going to, write down here, this is y equals, there it is. So go ahead, pause it, think about it, see if you can figure this out. Okay, welcome back. So if I look at this one, some of the things are going to jump out at me right away. Hopefully you're seeing this thing right here. That's the center line, right? And so I know the center line is exactly the d value. So I know whatever is going on in the front, I don't really know yet, but I do know that there's a +4 hanging off the back because that's the center line, okay? Everybody should get the +4. And then the amplitude is probably the next easiest thing. Amplitude It's how far from the center line I can get. So I just think about what is that distance right there. That is the amplitude. Well, 12 minus 4 is 8. So I know that the A value is 8. Now I have to decide, is it positive 8 or is it negative 8? And we'll get to that in a second. So those two values, they fall out pretty easily. And then we look at this and we think, okay, I'm only ever going to give you either sine or cos. Now, what are the hallmarks of sine? Well, the hallmark of sine is that it starts at its midpoint. And this does not start at its midpoint, or it starts at its center line, and it doesn't. So it is most assuredly not sine. So I know that this is 8 cos of something, and I still want to decide whether this is positive or negative. Well, I know that cosine naturally starts at the maximum of its range, and that's what I've got right here. Cosine is at the maximum of its range. So that means it's positive. I don't need to explicitly say it, but I'll just put it in there just to make sure that we're all on board. Next up, the stuff inside the brackets is always going to be the most challenging. Period length. I know that normally to figure out period length, okay, period length is always going to be equal to 360 divided by this b value, right? That's what period length. If I gave you a function, so if I gave you y equals the sine of 4x, and I said, what's the period length? You'd say, oh, period length is equal to 360 over 4. So you'd say, oh, period length is 90 degrees. We actually happen to know the period length of this one. Period length, recall, of course, is how far do we travel before it repeats the exact same pattern over again. Well, there it is right there. Its period length is 180 degrees. So I can come back here and I can say, all right, I've got this equation that I would use to figure it out, but I actually already know what this piece right here is. So the technical way would be, we're going to say, well, the period length is 180 degrees, and it's going to be 360 divided by some b value equals that. Now, a lot of you can just do that in your head, and you can say, oh, well, 360 divided by 2 gives me 180, so b has to be 2. And you're absolutely right, b is 2. But if it wasn't that obvious to you, you could think, all right, I'm going to solve this. I'm going to do that by, I'm going to cross multiply. I can put this over a 1, and I'm going to multiply up and multiply up. Well, 180 times b is 180b, and 1 times 360 is 360. And then I can say I want to get b by itself. Right now, b is being multiplied by 180. I'm going to divide by 180, divide by 180, right? And we're going to get then that, of course, type that into our calculator if we need to. We can see that, in fact, b is, of course, 2. So 2 is absolutely it. You probably have the instinct of that. Now, I'm going to need an x. There it is right there. So we have to have our x. Now I need to decide what the c value is going to be. Well, the c value, how does it come into play? It comes into play. It is our phase shifter. It's going to move us left and right. This thing starts from 0. So there is no phase shift. So if you wanted to, you could say, plus 0. That'd be fine. But the reality is, we're just going to write it as y equals 8 cosine of 2x plus 4. And there it is. That's the exact function that created this graph. Okay, so let's try another couple of those just to kind of get us proficient at this, and then I'm going to put some in for you to try for some homework questions. Okay, so let's try another one. We'll try one a little bit more challenging, not way more challenging, but a bit more challenging. Okay, frame it up as usual. Do this, and then this, and then didn't really give myself enough room. Nevertheless, here we go. And then we're going to challenge ourselves a bit more. There we go. There. There. Oh, didn't get it. And there. Okay, so I'll add some values now. So how about 3, negative 10, and negative 23. And I'm going to tell you that this is 50, and this is 410, and this is 770 degrees. Okay, those guys are in degrees. And then I'm going to sketch it in. All right, so here we go. We'll sketch it in. How about we go like this? You go ahead, you pause it, and then figure out what it looks like. Again, I'm going to write the general form. So it's y equals a sine or cos of something, of, I guess, bx plus c plus d. So go ahead, pause it, give that a whirl. Okay, so let's start going through this. So D is our center line. Pretty easy, we can spot that. There it is right there. It is -10. So I know whatever is going on at the front, I know there's a -10 hanging off the back to ensure that we have a center line at -10. A is our period length. Or sorry, excuse me, it is our amplitude. So amplitude is how far from the center line we can get. Well, how far is it from -10 up to 3? Hopefully we can see that's going to be 13. So it's got a period length. I know that there's going to be a 13. Now, it's going to be positive or negative. Well, we're going to wait until we figure out if it's sine or cos. Hopefully it doesn't take you long. We can see that, hey, it starts right at our midpoint. So because it starts at the midpoint, I know that that means that it is in fact, of course, going to be sine. So I'm going to come back here and I'm going to say this is sine of the stuff. Now, the stuff in the brackets, always the most challenging. Okay. Now, sine starts at its midpoint normally, and it goes upwards to begin with if it's positive. Well, it starts at its midpoint and it goes upwards to begin with, so it's positive. Now, B and C, always the most challenging. Go B next. Okay. So B is going to be next here. So I look at this and I think, all right, how long is the period length? How far does it have to go before it repeats the exact same pattern again? Well, if we look at this, it goes all the way from here to start and here to finish. So the distance between those is 410 minus 50 is 360 degrees. So because it's 360 degrees, we know the period length is the normal, quote unquote, period length. So, I mean, we can still do the same equation. It will always work. We can say, oh, well, period length is equal to 360 divided by whatever the B is. Okay, fine. And I know the actual period length is going to be 360. So I come back here and say 360 is equal to 360 over B. Well, what do I have to divide 360 by to get 360? Well, 1, right? So we know that that's got to be 1. So we're going to come back here and we can actually put in 1x. Now, the C value. The C value helps us figure out what the phase shift or the left and right movement is. How has this moved? Well, there's different ways there's lots of different answers that would actually work here, but we always kind of think about how far did it go from, sort of from the origin to where it started. And in quotes is what I say started, because it doesn't really start because it keeps going the other direction as well. Like it really kind of keeps going like this. However, we look at this as being our start. How far is it shifted? It is shifted 50 degrees, right? There is 50 degrees. And it shifted to the right. Now, the stuff inside the brackets is backwards. So because it's to the right 50, we are actually going to say minus 50. And there it is. So I'm going to rewrite it so it's a little bit cleaner. We're going to have that it is 13 sine of x minus 50 degrees minus 10. And there's that function. That's it exactly. Okay, let's try another one. We'll kind of go to the maximum spice level on this one. This is as hard as I would ever give you, regardless of circumstances. This is probably as hard as I'd ever give you. So here we go. So how about we were up here and here and here, there, there, and there. Okay, add some measurements in here. So -1, 7, -9. I'm going to say that this is 20 degrees. And this is 200 degrees. And this is 180 degrees. And then we're going to go like this. So I'm going to grab the right color that I want to draw it in. We'll try our best to make it smooth. Oh yeah, that's just lovely smooth. So general form, y equals a of sine or cos of bx plus c plus d. So go ahead, give this one a roll. This one is pretty challenging. Give it a shot. Okay, welcome back. So let's chip away in the same order we always do. Center line, right there, center line, which means that that's D. So I know there is a -1 on the back. Amplitude, how far does it go from its center line to its max? Or if you really want it, how far does it go from its center line to its min? It's going to be, has to be the same. In fact, it's maybe even easier to see it on this one here. From -1 down to -9, I can see, oh, that's a difference of 8. You might think, oh, it's -8. And ironically, it is here, but we're only just talking about distance. So the amplitude I know is 8. Okay, so the amplitude is 8. Now, sine or cos? Well, hopefully right off the bat you can say, oh, it didn't start from its midpoint, means it's got to be cosine, right? So there's my cosine. And then it starts at its minimum, right? So cosine normally starts at its maximum. This one starts at its minimum. That means that this is going to be a negative. We're good, we're good. Now, figuring out the b value. I need to know how long the period length is. Well, it starts at 20 and it finishes one full period length at 200 degrees. So if I look at this, I think, well, how far is it from 20 to 200? And you can probably do that in your head. It's 180 degrees. Okay, so it's got a period length of 180 degrees. But I've got that equation that says period length normally is equal to 360 divided by b. Now, this is the same period length we did earlier on. I'm just going to re-emphasize it again. I know the real period length is 180. So I'm going to put 180 in over here. 180 is equal to 360 over b. And I think, what do I have to have as my b value to make this true? My b value has to be 2. So I know it's going to be 2x. Now, this is where it gets really spicy, right? And I'll tell you that even with my, my grade 12 advanced functions kids, if they're going to make a mistake on this question, and probably at least a third of the class, if not more, would, it's going to be on this piece right here. Now, I can see that the phase shift is 20 degrees, and it's shifted to the right. So if you remember the last one, if we're shifting to the right, it's opposite to the sign we think, so it's going to be minus. Now, a lot of people are going to put in minus 20. And that is an extremely common mistake. And you might say, well, how's it a mistake? I'm going to show you why it's a mistake by kind of proving a counterexample. If I asked you to graph this, you get the right center line, you get the right amplitude, you get the right function, you get the right period length. When you went to figure out what the phase shift was, hopefully you would remember my lesson. My lesson said when you want to go for a phase shift, we take the whole set of brackets and we set it equal to 0 and we solve. Well, look what would happen if I did that. 2x minus 20 is equal to 0. I'm going to move that over. So we'd have 2x equals positive 20. I'm going to divide by 2. I'm going to divide by 2. And I get x equals 10. Oh, crap. We just found that the phase shift would have been 10 degrees to the right, but I needed to be 20 degrees to the right. So some of you might just make a logical conclusion. Well, it's got to be minus 40 then. And that's actually true. It does have to be minus 40. But here is my tip for how to do that. You take the phase shift that we know that it is, and you go ahead and you put it in. But what you do is you put in an extra set of brackets. I've gotten rid of my x there. You put in an extra set of brackets. And you might say, well, why do I do that? Well, the reason I do that is, well, that's pretty ugly. Nevertheless, if I now take the whole set of brackets, look what would happen. I don't know if I'm going to be able to get that same green back, or whatever color it is. It's pretty close, I think. If I take this set of brackets now, 2 bracket x minus 20 equals 0. First thing I'd have to do is I'd have to distribute that 2. So I'd get 2x minus 40 equals 0. Move that over. We're going to get 2x equals 40. Divide by 2, and we get now what we want. X equals 20 degrees. So my hint for any time that you need to figure out what the phase shift, the C value is just pick the obvious answer and put in an extra set of brackets. And that extra set of brackets will make it all work out nicely. Okay, so that's what I would like you to do. Now what I'm going to do is I'm going to stop the video here, but I'm going to also post on Classroom this same lesson. At the bottom of the lesson will be a few more graphs, but you don't need to watch me drawing them. And I'd like you to give those a whirl. Okay, thank you.